Hi, welcome back. This is Professor Ridge. Today's lesson is on section 7.1, the parabola. So we've done parabolas before, and in this section, this chapter, we're going to be talking about conic sections. So we're going to look at parabola in this context as a conic section. So a conic section is formed when a right circular cone with two parts is intersected by a plane. Okay, so basically you have a cone with two parts, and if I were to slice it, I'm not going to draw it because I'm going to butcher it here, but anyway, if you were to slice that cone, and the idea is if I sliced it where it's parallel, I said I wasn't going to draw it, but if I were to slice it where it's parallel to this edge here, the resulting intersection of that plane would give me a parabola. Okay, so that's a pretty bad attempt, but there you go. Okay, a parabola is a set of all points in a plane equidistant from a fixed line, and we call that the directrix. And a fixed point that's not on the line, we call that point the focus. Okay, so the idea is we get a fixed point, which is going to be our focus. We get a fixed line, which we'll call the directrix. And then every point that's equidistant from the fixed point, the focus, and the directrix is on the parabola. So this point here is it's going to be the vertex, which we'll talk about a little bit. And then what you're going to get is something like this. And I'm just kind of freehanding it, so this may not be exactly right, but the idea is if I take this point here and measure that distance, and then the perpendicular distance to this line, by definition, B1 has to equal B2. Okay, so the distance from the point on the parabola to the focus and from the point on the parabola to the directrix, that has to be equal. And then from that definition, we can use the distance formula to figure out the equation of this of a parabola centered at 0, 0. So I'll leave that for you to look if you're interested, but let me write down the equation for you. Okay, so the standard equation of a parabola with the vertex 0, 0, so right here's our vertex, 0, 0, and directrix y equals negative p, so p is the distance from the vertex to the focus, and also the directrix would be y equals negative p. Okay, so that's p units away also. So the focus is going to be at 0p. And then the equation is going to be x squared equals 4py. Again, the idea is if I were to put any xy here and measure the distance from xy to 0p and set that equal to this point, that would be equal. And you can look in the book if you want more on that. But once you solve that equation, you'll get x squared equals 4py. So again, p is the distance from, so note, p equals distance. Okay, so we can also do the same thing if we have a parabola opening sideways. So this one, we have a vertical axis symmetry, that's x squared equals 4py. And then we can do horizontal. Okay, so the standard equation of a parabola with vertex 0, 0, directrix x equals p is y squared equals 4px. And again, you can derive that formula using the distance formula. But again, I'll just leave it at that. So if this was x, y, vertex is 0, 0. So that's your vertex. And then directrix is x equals negative p, so it's a vertical line. This is x equals negative p. And then p would be, that point would be your focus, which would be p comma 0. And then your parabola would open to the side. Okay. And the thing to keep in mind when you're doing this, your parabola always opens towards the focus, away from the directrix. All right, let's look at an example. We're going to graph x squared equals 8y, find the vertex, focus, and directrix. Now note, the one that you should be familiar when you're thinking of it as a polynomial equation, y equals x squared, that one you should be real comfortable with. And so y equals x squared, so let me just kind of put that in here. If I have y equals x squared, you should know 0, 0, 1, 1, 2, 4. And it's a parabola that opens up. Okay, so that you should be real comfortable with. Let's review. So this is thinking in context of a polynomial, a quadratic equation. Now when I'm thinking in context of the conic section, what you do is I kind of connect it back to here. The one I know that opens up and down is y equals x squared. So if I have the x squared, that means it opens up or down. And the number, instead of having a in front of x squared, you got this 4py. So this 8 has to be equal to, this is your standard form, right? This is the general equation. So the 4p has to be equal to 8. So the 4p has to equal 8. So my first thing is figure out what p is. So you're going to solve for p. And you're going to connect it. Remember, this is the equation, the standard equation. And it's x squared equals 4py. The equation that I want to graph is x squared equals 8y. So the 8 must be equal to 4p. So p equals 2. So now I know that p equals 2. I know my vertexes from the standard form. So just look at the notes that I just wrote. Is 0, 0. I know the focus is going to be p, or 0p, because it's opening up. 0p, so that'd be 0, 2. And my directrix is going to be the line, let's see, directrix will be y equals, and then you take the opposite of p. So this is just standard, right? Standard, 0p, and y equals negative p. So for this equation, x squared equals 8y, we figured out p is 2, so 0, 0, the focus is 0, 2, and the directrix would be y equals the opposite of 2, so negative 2. So this is the directrix. Y equals negative 2 is my directrix. My vertex is 0, 0. My focus is 0, 2. Now, the book doesn't talk about this one, but there's this common point that we called, if p is 2, that's that distance, or the absolute value, p is 2. If you go twice that distance, that's 4. You're going to go straight out from the focus 4 units. And we call this point here the point from the lattice rectum. And we're going to go 4 the other direction. So that point there is on my graph, and then I just make my parabola. So you go twice what P is. And notice the 4 plus 4, there's your 8. So that's where the 8 comes involved. So you just go from the focus, you take twice whatever P is, and go each direction from the focus. So that gives you this point and this point. It gives you the 4, 2 and the negative 4, 2. And then you can plug it into the equation and see that those points are there. And that's all you need to do. Let's try another one. So let's graph y squared equals negative 4x, and you're going to find the vertex, the focus, and directrix. So again, I think about the one I'm familiar with. Y equals x squared is the one that opens up. So this is y squared. So that means it opens sideways. Okay, so again, if we think of the standard equation from the formula that I gave you, it's going to be y squared equals 4px. So the 4p, and then this is the one I'm doing. So I'm going to graph y squared equals negative 4x. So the 4p has to be this negative 4. So let's solve it. So p must be negative 1. Okay, so again, to do the vertex, the standard form, the vertex is zero, 0. So this one is going to be 0, 0. The focus is P0. So this one's going to be negative 1, 0. And then the directrix is y, no, this one's going to be x equals the opposite of p. So the directrix will be, for this one, x equals the opposite of negative 1, which is positive 1. Okay, so that's the directrix. Alright, now we're ready to graph this thing. Okay, so vertex 0, 0. My focus is negative 1, 0. So here's my focus. Directrix is x equals 1. So x equals 1, that's my directrix. And then, okay, I'm going to get the lattice rectum point. So if p is 1, twice p would be 2. So the absolute value of p is 1. Twice that is 2. So I'm going to go 2 units from the focus. Up 2, down 2. And then I can make my parabola like that. And remember, the parabola opens in the direction of the focus, away from the directrix. Okay, so that's the standard one. Now let's talk about moving the vertex. Okay, so let me just define that lattice rectum again, because we'll be using that. So again, it's not covered in this book, but it's that's how I find those 2 points real easily. So if you have a parabola, if this is P, that's the vertex. The lattice rectum is the chord. I'm going to go twice P here, twice P that way. So the lattice rectum is that chord, this piece here. That's my lattice rectum. And a funny name, but that's what it is. Okay, and notice 2P plus 2P, that's 4P. So if this is P, absolute value of P, I should say. P is positive, no problem. So that would be my directrix. And it's the same thing if it doesn't matter which way it's opening. Okay, so now let's talk about moving the vertex. Okay, so the standard equation of a parabola with vertex HK and vertical axis symmetry is x minus h squared equals 4p y minus k. Now note, both the h and k in the vertex is hk, and then in the formula it's x minus h and y minus k. So that tells you that the signs are, you change the signs, right? So if this is h, this is minus h. Here's k, this is minus k. So they're opposite signs. So just keep that in mind. So the vertex is hk, which we already wrote that. The focus is h, comma, k plus p. And the directrix is y equals k minus p. Okay, and then the standard equation of a parabola with a horizontal, with vertex hk and a horizontal axis symmetry, you just switch the x and y. But notice it's the k, the y coordinate's always with the y coordinate, x coordinate's always with the x coordinate, the hk. So h is over here with the x. Okay, it's always going to be with the x. And k is always going to be with the y. And now since this p is the still the distance from the vertex to the focus, and since this has a horizontal axis of symmetry, and that's going to be x equals, not x, y equals whatever the y coordinate is. So in this case, it'll be k. Since it has horizontal axis symmetry, the p coordinate to go from the vertex to the focus, you're going to add p. You're going to add p to the h coordinate, the x coordinate. Okay, so it'll be h plus p, comma k, whatever k is, because you're not going to go up or down. You're going to still be at that same point. All right, let's try one of these. Alright, so we got y minus 3 squared equals negative 12, parentheses, x plus 2. Okay, so first you got to decide, is it horizontal or vertical? And remember what I said before, the one that opens up and down, that's y equals x squared. This is y squared, so it's horizontal, opens side to side. So if I think of the standard form, which I just wrote up there, y minus k squared equals 4p x minus h, and we want negative 12 must be the 4p. So p must be negative 3, so it's going to open to the left, because p is negative. So now, and it's opening side to side, so we know that the focus, okay, so we're going to find the vertex first, is hk. So for our problem, the vertex is going to be, h is the 2, the opposite of that, so it's negative 2. And the k, you got y minus 3, so that would be plus 3. Now for the focus, that's going to be equal to, the standard one is, now again we're going side to side, so we're going to add it to the h coordinate, the x coordinate. Okay, so our focus here is going to be -2 plus p, which p is -3. So that's going to get us -5, 3. And then our directrix is y equals, not y, it's x equals h minus p. So we get, so for our directrix, we get x equals h minus p, so it's -2 minus 3, so x equals 1. Right, so now we're ready to graph this thing. Hopefully I have enough room here. It's opening to the left, and we're going to start at -5, 3. Okay, so vertex is -2, 3, right here. The focus is -5, 3, right here. So through those, through the focus and the vertex, that's your x symmetry, which is x or y equals 3. And then we're going to get the lattice rectum point. So if p is the absolute value of p is 3, so twice 3 is 6. So I'm going to go down to, so let's see, 1, 2, 3, 4, 5, 6. Oops. From here. 6. 1, 2, 3, 4, 5, 6. And then I just make my, oh, I forgot to do my directrix. That's 2, this would be the directrix. That's x equals 1. And then I'm going to make my parabola. Alright, so let's try another one. Okay, so let's find the vertex, the focus, the directrix, and then draw the graph. So on this one, it's not in standard form. So my first step is I got to put it in standard form, which, look, we got x squared and that's it, no y squared. So we're going to get the standard form. Remember, standard form is x minus h squared equals 4p y minus k. So what we need to do is get the x squared plus the 4x, keep that on one side, and we're going to move the other two terms to the other side. So it'll be -8y plus 4. And then what we're going to do next is we're going to complete the square. So plus blank, plus blank. So remember, you take half the middle term. So the middle term's 4. You take half of that, square it. So we're going to divide by 2, and then you're going to square. So 2 squared is 4, and you add it to both sides. Now, whatever this number is in front of the y, you got to factor it out both terms, and if it's negative, you factor out a negative. So we're going to get x plus 2 squared equals -8, y minus 1. Now, if it was -8y plus 7, you still factor out a -8, and then you would have y minus 7/8. Okay, so whether it divides evenly or not doesn't matter. You factor out whatever that coefficient is. All right, so now we got it in standard form, And we want to note that negative 8 is going to be our 4p, right, for standard form there. So that tells us p must be negative 2. And again, I should be thinking, okay, I got x squared, that's opening up and down. If p is negative, that means it opens down. So my vertex is going to be hk. So, and remember, you change the sign, so it's negative 2, positive 1. The focus is going to be, now this is opening up and down, so the focus is going to be, let's see, which way would the focus be? So if it's opening up and down, the focus you're going to add to the y coordinate, to k. So it's going to be hk plus p. So that's going to get me negative 2, 1 plus negative 2. So I drew my picture opening up, but it opens down. So that's going to be negative 2, negative 1. And then the directrix, that's going to be, remember the standard form, directrix will be y equals k minus p. So we're going to get y equals k, which is 1, minus p, so minus a minus 2, and y equals 3. Okay, so now we're ready to graph. Okay, so the vertex is negative 2, 1. P is, absolute value P is 2. P is negative 2, so here's the focus. And the directrix, you go 2 units the other direction. That's y equals 3. And then remember the trick for plotting the 2 points for this. If the absolute value of P is 2 units, then you're going to double that. If that's 2 units, you're going to double that, which is 4. 1, 2, 3, 4. And go 4 units each way from the focus. 1, 2, 3, 4. And that gets you those points, and I think that should be enough to graph it on my math lab. Alright, so there you go. And then of course the symmetry goes down the middle like that. Okay, so let's find an equation of parabola satisfying the given conditions. It has a focus of 3, 2, and directrix is x equals negative 4. Now you don't have to draw the graph. I just like to make a little quick sketch. You know, I'm not going to do it perfect. 1, 2, 3, 2. Focus. Directrix is x equals negative 4. Okay, so what we know is that the vertex is going to be halfway between the directrix and the focus. So halfway, so how far is it from, or we can figure out this point here. This is negative 4, 2, and find the midpoint between these 2 points. That would be the vertex. So the vertex is going to be, and how you find the midpoint, you're going to add the x coordinates, add the y coordinates. Now since the y coordinate's same, obviously you get the same. So the vertex would be negative 1/2 2. Okay. So the vertex negative 1/2, 2. And then once you get that, you know, okay, and it's going to open towards, it's opening side to side. It's going to open towards the focus. So it's opening, it's a horizontal X symmetry. So now we're going to write the standard form for that. Opening sideways is y minus k squared equals 4p x minus h. So we're going to plug in what we know. Y minus k is 2. P we got to figure out. So I'm going to leave that blank for a moment. And then x minus h. H is negative 1/2, so it's minus a minus 1/2, which becomes plus 1/2. Now we just got to figure out p. P is going to be that distance from 3, 2 to negative 1/2, 2. So 3 minus a 1/2. So P will be 3 minus a minus 1/2, which is equal to 3 1/2, which is 7/2. Okay, and let's simplify. 4 times 7/2 is 14. X plus 1/2. We got y minus 2 squared. So that's the equation of the parabola that meets the given conditions. Alright, so that concludes the lesson for 7.1. Go to my math lab and complete your exercise there, and I'll see you next time.